it will just record me talking. So, but we're glad that you're here today, and we're glad that you're wanting to learn how to save water in your landscape. So we're going to get started with irrigation with water conservation in mind. Okay. And I just converted this slideshow, so I might see some errors in here that I point out. But first we're going to talk about some water facts. So some interesting stuff going on in Florida. Of course, these projections were made a few years ago, and you can see on the left, the map is showing the 2010 water use. And I'm sorry, not water use, but development, where the development is happening here in Florida. And then on the right side, you can see the 2070 projection. Now, that was projected about 3 years ago. We've seen some changes here in this past year. We have a lot of people coming to Florida in bigger numbers than we originally projected or expected. So we may see some adjustments to these maps upcoming, but you can still see the Tampa Bay area, which I will try to point here. Hopefully you can see my pointer. So here's the 2010, you can see the development there. This is Manatee County. You can see this blue line is the Manatee River. And then when we come over here, if you look at this little blue line, the Manatee River, you can see there's a lot more red above the Manatee River. And we know that that's what's going on here right now, right? We have a lot of development north of the river that's really happening, plus out east. And you can see the state as a whole. You can see the center here currently, not as much development, but you can see a lot more development as we move through time. That's our projections anyway. Okay, there we go. So here's a little bit up close to the Tampa Bay region. Again, this is the red is developed areas. So all these people are going to need water, right? As they come in, we're going to need to have water for everybody. That's important. So we want to be sure that we are conserving as much as we can so that there is water use for everyone. We are fortunate here in Manatee County that we have a good water supply. Our county commissioners back in the early 70s, 80s developed the reservoir out at Lake Manatee. And so we have surface water runoff that is treated and then put through the pipes for drinking water. And as long as we don't have severe drought conditions, that supply of water has been pretty reliable for us and has put us in better shape compared to other communities, other neighboring communities. We currently sell some of our water down to Sarasota County because we're not using all of it. So in the future, as we grow, we may not be able to sell it to other counties anymore. We may have to keep it for ourselves. Okay, so when we look at the breakdown of water usage, you can see, especially folks with the outdoor irrigation systems, about 50% of the water usage is going outdoors. And that's where I think we can really make a big change, a big difference. I know for new developments here in Manatee County, to get building permits, you have to go with the lowest quality water that's available in the area when the development's built. So if there is a reclaimed line running by, then the developer has to attach to that reclaimed line. They can also use stormwater ponds within the development, and that is also called reclaimed water. So when you have purple pipes in your community, you could either have reclaimed coming from the reclamation plant, or you could have reclaimed coming from a stormwater pond. And then there's also wells. Communities often will have wells that they're pulling from groundwater to use for irrigation. But then we have some other things. As features and fixtures become more water efficient, our dishwashers now are working on less water than you can use to wash the dishes by hand. That's the statistic, is that the dishwasher actually uses less water than you would use to rinse and wash those same dishes. And our toilets are becoming more and more efficient. So these numbers are going down. I don't know if they'll continue to go down if we found the most efficient ones that we're going to find, but these numbers do continue to go down. Shower fixtures are more efficient. Washers, the front loading washers are more efficient than the top loading. They don't use as much water. Honestly, your laundry is a huge water user, anywhere from 35 to 50 gallons a load it can use. So you know, make sure you're doing full loads, not partial loads when you're washing clothes. But today we're going to really focus on this outdoor water use and see if we can figure out some ways to conserve water in our outdoor usage. So that is going to, you know, focus on the discussion of our landscape irrigation system. So it is the largest appliance in that it uses that 50% of the water use. And you know, it can be one of the most wasteful. We have a mobile irrigation lab here in Manatee County that I'll be talking about as we move through the presentation. But we see huge places where people can save water out there, or where water is being wasted. I'm filling in right now because we're down a person. So I was out yesterday on 2 sites and the rain sensor was not working on either site. Means that when we have rain, those irrigation systems are running, even if we've had adequate moisture. So that's a lot of water that's being used unnecessarily. So why do we need to irrigate? So I'm going to actually ask you guys this question. So if you want to turn your mics on, I like to have some interaction with folks. So why do we irrigate? Any ideas?
Taking care of our lawn and plants and our trees.
Yeah, so the statistic in Florida is that we get 52 inches of rain a year. That's the average, 52 to 53 inches in our area of rain. So then we're going to tell you that if you get an inch of water in a week, that you don't need to irrigate that week. If we've received an inch of rain in a week, you don't need to irrigate that week. So if we're getting 52 inches of rain a year, and there's 52 weeks in a year, why would we need to water?
Just to keep things green. I mean, people like green.
Well, does our rain come an inch a week?
No.
No. Our rain comes, you know, 12 inches in 1 week, and then we don't see it for a month, right? And that's why we need that supplemental water. And that's what it really should be referred to. I wish they would call it a supplemental system instead of an irrigation system, because it's supposed to supplement rainfall. It's not supposed to, you know, be the only source of water that these plants get. It's to fill in the gaps. When we don't receive adequate rain. So we have extreme weather here in Florida, right? In the summertime, we really experience some major extremes when we head into hurricane season, which is starting to be talked about already. And then we have these sandy soils, which really don't hold water all that well. So that drives the need up sometimes for more irrigation. And then we have a lot of folks that move here from other places, and they like to bring with them things that they recall from their home state. And those same plants may not do as well here and may drive the need for maintenance up in the landscape. So we're going to talk about how to select some plants that do well here in Florida, and maybe drop some of those tourist plants out of our landscape, some of those plants that may require more water. Petunias are beautiful. I've been to South Dakota, North Dakota, and seen petunias in the middle of the summer doing gorgeous. I'm going to ask that you just, if there's an echo, if somebody could mute, I don't know who it is, but if you could just mute for a minute, that would be great. But in South Dakota, it was gorgeous. And these petunias were blooming full bloom in the summertime, the heat of the summer. In Florida, that's not going to happen. Petunias their season's over with right now. We had maybe a brief season in cool weather, but it's over. And if you're trying to keep petunias alive right now, you're using a lot of water to do so. Same with impatiens. That's another one that people like to have that uses a lot of water. So based on over 2,000 irrigation evaluations, which this was done in the Tampa Bay area, and Tampa Bay Water actually paid for this study. They looked at 2,000 irrigation evaluations and found a third of the irrigation water was wasted due to inefficient design and maintenance of the system. So these irrigation systems are put in when you build your house. A lot of times they're just part of the home package. Landscape package A includes the irrigation system. And a lot of folks just don't know how to maintain them. They don't understand what's involved with the maintenance, or that they need to maintain them on a regular basis, right? As long as they see water spraying out of the irrigation heads from time to time, they think that everything's fine. It's all working wonderfully, right? But these things do have maintenance components to them. And if we keep them in good repair, then we can save a lot of water by doing that. I want to talk to you briefly about our rebate program here in Manatee County before we get started on the nitty-gritty of the landscape irrigation system itself. So Manatee County, in efforts to try to conserve water, is offering rebates to homeowners that I see someone with the camera. Great, please feel free to take pictures. We can also send this out. Everybody that's attending today, I will send the rebate, and Dina is on here. So Dina, you help remind me, or actually Dina will send our rebate brochure out to you that details all of this. So we'll get that out to you. So a cistern, it may not be, there's a rebate 50% up to $500. Cisterns can be rather expensive to get them installed properly. So know that. I'm not sure. I'm going to try to just go through here real quick. I'm sorry. I'm getting feedback or something. Okay. So cisterns are part of the rebate program. And I do need to back up and say the rebates are available to Manatee County utilities customers. So you have to be a utilities customer. There's some other things that qualify you. You have to have a backflow valve. Your home has to have been built within a certain time frame that you wouldn't have some of these water saving features. But then there's some other pieces that still, as long as you're a Manatee County utilities customer, you can qualify for. So like the wells, alternative sources of water, community wells, those kinds of things, they'll consider just as being a utilities customer. Because why? They want to get you off of their pipe. Plain and simple. We have a consumptive use permit that we get through the Southwest Florida Water Management District as a utility or as a county, and we need to keep our consumption use at a certain level. And as development grows, use grows, right? So the more people we can get on alternative sources of water for irrigation, the more water we can save and the more development we can do. And I know that that may not be what's exciting to a lot of people. A lot of folks don't want to hear about more development. I am a Florida native. I was born and raised here in Manatee County. I've seen a lot of development. It's not going to stop. We have a wonderful place to live, and people are going to keep coming. So we just need to look for ways to just do it sustainably. And if you have a voice, if you want your voice to count and to be heard about development issues, I would say that's really what should be focused on. Is I don't think that we're going to ever stop development, but if we can do it in a better way that works better with resources, that is a smarter way to develop, is working within what we've got. So please, by all means, use your voice for that message. Okay, so that's some of the rebates. But what we focus on here at the extension office is helping folks get some of these type of rebates, and that is for a rain sensor. So if you do not have a rain sensor currently, or it's not working properly, they'll pay up to $150 to have the rain sensor replaced or installed. That one is not a percentage rebate, that's 100%. They'll pay up to $125 of the cost of that. The other one is the soil moisture sensor. So we know through research that when soil moisture sensors are installed appropriately, that they can save a lot of water. So our utilities department is rebating, again, 100% up to $250 on those. And if you don't know what a soil moisture sensor is, as we move through this presentation, you're going to learn what that is. Okay. Then we have some irrigation and landscape rebates that you can qualify for. So the landscape retrofit would deal with your plants, your mulch, converting turf, which requires more irrigation, to landscape beds. You can qualify for some rebates to do some of those things. I will say, to qualify for a landscape retrofit, you do also have to do some irrigation changes. And so the irrigation, whoops, where did that piece go? Oh, it's down here. I'm sorry. I looked at the top and didn't look at the bottom. See, I'm working on this presentation and I need to put these on different slides. So the irrigation retrofit would be, let's say you have spray heads in your landscape beds, and we know that micro irrigation can do a better job of irrigating your landscape beds. So to retrofit from those spray heads to micro irrigation, you could qualify to get 50% of that, up to, Dina, can you chime in and tell me what the top is? I've forgotten. $1,250?
Yes, it is $1,250.
Okay, thank you. So up to $1,250 is the max the utility department's going to rebate you, and that would include irrigation and landscape repairs. And so then you can see number 8, you may need to have a whole system replacement. Whole zone or multiple zones just may need to be torn out and replaced because of leaks or problems with it. I will say that if we come out and you don't have a irrigation system, they're not going to give you money to put one in. We're not looking to put in more irrigation. We're just looking to try to make the irrigation system that you have run more efficiently and conserve water in the landscape. And that's what they're trying to rebate and provide some, funds to help people with. Okay, so there's one of my mistakes right there. Making your landscape smarter. Long dramatic pause. Smarter. That space isn't supposed to be there. Okay, so Florida friendly landscaping is one of the ways that we can make our landscape smarter. There's 9 principles to Florida friendly landscaping that I am not going to go through, but we have lots of other classes that we can teach you all about these, either in general as all nine, or we can get into each one specifically in a class. But right plant, right place is the #1 principle, and it's #1 for a reason. We want to find the right place for the right plant in our landscape. And what does that mean? Well, when we go to Home Depot and we see I can't say Home Depot. When we go to a big box store, like Home Depot, Lowe's, Costco, even, these big box stores, and they have plants. And they put the pretty purple one right by the checkout, so everybody sees it and wants to take it home. And you grab that purple plant, purchase it, and bring it home, and you plant it right by your front door. And the first thing that, you give it some water, give it some TLC, and the next day you come out and it's like, bleh, right? It's droopy, not doing well. What could be the reasons that that's happening? And I did hit mute on you, so if you're going to speak, make sure that you unmute yourselves. I hit mute all. So why would our plants, we've planted them, why would they be all droopy and terrible looking?
Just not in the right place.
That's right. So it could have been that it's a full shade plant and we put it in full sun. So what would our first response be when we see a droopy plant like that? What are we probably going to start doing to it immediately?
Water.
Yeah. And then maybe, oh, it might need a little fertilizer, a little food. And all of those things could be in vain because it's just in the wrong place, right? So we need to do a little research, a little homework, and that's where we're here to help you. The Extension, University of Florida has great information on the internet. Our extension office has great information here. You're welcome to come in. We would welcome you. You just have to wear a mask right now, but we would welcome you to come in. We have a plant clinic that our wonderful Master Gardener volunteers volunteer to man from 9 to 4 on every work day but Wednesday. They're not here on Wednesdays. They train on those days. So Monday, Tuesday, Thursday, Friday, you're welcome to come in. We have programs. We have something called the Landscape Assistance Program that you can come in and spend, well, they're probably doing it via Zoom right now, but maybe in the fall, if you'd like to come in person or do it via Zoom currently. A couple of Master Gardeners will sit with you and talk about your specific landscape. They'll bring it up on a Google map. You can show them photos, soil samples. You can discuss what kind of plants you're looking to install, and they'll work with you to find the right plants for your place and your areas in your place. So there's a lot of things to look at with that right plant, right place. And that's why I'm spending a little bit of time on this one. I'm not going to go through all of these quite like this, but it is really important that you do some of that homework. Again, we can help you with resources, telling you what the plant needs are, how much water they need, light, pH is really important. The pH of the soil is very important for a lot of plants. So we can help you there. Watering efficiently, that's what we're going to talk about today. Mulch can help retain moisture to the root ball of the plant, which is where it's needed. It's really at that root ball. Fertilizing appropriately, again, we can help you with that. And that is super confusing. Let me tell you, I teach fertilizer licensing classes to landscape professionals, and it's confusing. So as a homeowner that maybe not looks at this kind of stuff often, you might need some help in figuring out how much fertilizer you need in your landscape. Let us help you with that. We've got calculators. We just need to know your square footage, or we can pull it up on the Google map again and measure the area and help you figure that out. But it can be very confusing. And I don't ever want to hear somebody say, oh, I just put a bag in the front and a bag in the back, because that bag may cover 5 acres, right? We got to look at the amount of nitrogen and those types of things that are in the bag, not just I put a bag down, in this area. So lots of important information there, and we'll help you there if you need some help. Managing yard pests responsibly is another principle. We should not be spraying on the 15th of the month just because it's the 15th of the month. Okay, if we don't have any pests, why are we treating? So it's when you hire a contractor that comes out to spray your landscape or your home, they should be scouting. They should be looking for pest problems. And if there's not any pest problems, then you're paying them for the knowledge to know that there's no pest problems right now and we don't need to spray. That's still a billable service, is to have that knowledge. But if there is a problem, then it should be a spot spray. It shouldn't be that somebody's dragging a hose through your landscape and spraying from one corner to the other just because it's the 15th of the month. We can create a lot of problems in doing it that way. We want to reduce stormwater runoff as much as we can. We don't want to add to runoff. Things like redirecting our downspouts from on the driveway. We see that a lot. Downspout comes right down the house onto the driveway, which forces it right out into the road. Maybe we could redirect that into our landscape, and the landscape could benefit from the extra moisture. So we want to look for ways to reduce that. Rain barrels, that cistern that we talked about earlier. There's lots of ways we can do that. Attract wildlife. There was wildlife on your site before the house went up. right? At some point there was wildlife there. And then we developed the land and we took away a lot of food sources for our wildlife and a lot of water sources too, and habitat. So we want to try to recreate some habitat, some food sources, plants that berry, plants that seed for the birds, maybe some water sources for them. And then we want to protect the waterfront. Again, we live in a gorgeous place. We are a coastal community. We've got the Manatee River, we've got the Gulf of Mexico, we've got the Intercoastal, we've got the Braden River. We have a lot of coastline here in Manatee County, and we want to protect that because that's probably one of the reasons you moved here is our beautiful water vistas that we have all over. I know I do. I have a family that we all love to boat, fish, scuba dive, you name it. On the weekends, we're probably next to or in the water. So I'm a big fan of protecting that water, which is why I teach those landscape professionals pesticide and fertilizer licensing to try to help them do it in the best way possible. So again, use this as a resource. These are my fun Master Gardener friends that are up at Epcot at the Flower Festival. So they don't all dress like that, unfortunately. Life would be fun around here if they did. But these are some cute ladies. But we do have Master Gardeners here. We also have paid staff. Our Master Gardeners are volunteers, but we also have paid staff, extension agents that can help diagnose issues. And please utilize us. We are a free resource for you. Your tax-paying dollars pay for us to be here. So please use us. So why do some landscapes fail? To begin with, so look at the way we develop. We dig stormwater ponds and put that soil up on top of the ground. We take soil that was 20 feet down and flip it and put it up on top. And why does that matter? Well, in a natural soil profile, and I saw that there was a soil scientist on here, so feel free to chime in if I say anything incorrectly or if you want to add to. And in a natural profile of the soil, we have organic material up at the top, then some sandy soils, then it gets harder, more compact as we go down. This is a wonderful filtration system for water. That organic material up at the top can actually get pollutants that bind to it and stop it from moving down through the sandy soils and into the harder compact soil. As the water moves down through, when it gets to that compacted soil, it moves slower, filters some more, but moves slower before it gets down to our aquifer. So now what we're doing is we're taking that organic soil that's up at the top, and then we're digging, whoops, here we go. We're digging down 15, 20 feet for these stormwater ponds, and we're flipping it, right? We're putting that hard compacted soil on top, and then our organic soil is getting covered up. Well, that hard compacted soil is hard to grow plants in. It is beautiful for developing houses on because it's hard compacted soil. So we have less shifting, less cracks and foundations and things like that because it's really hard soil. But plants, different story. They go to put their little roots out into this hard soil, and it's hard for them to get established sometimes. So that's one of the ways that landscapes fail, is just the soil is not good soil for plants. We've done some research at a place called On Top of the World, where they've added 1 inch of compost on top of the landscape that was developed like this, with that compacted soil. They just put 1 inch of compost on top, and they've seen amazing results from adding that organic material into that, compacted soil to help with the plants. It helps with water retention, and it helps with the plants, because think about that really hard compacted soil. When you water, where does it go? It's not percolating down into the soils. It's running off mainly, right? And we're going to talk about cycle and soak here in a little bit that can try to help with that situation. But for the most part, those really hard compacted soils, it's going to run off. Okay, so here's some more of that. You can see they're going down into the really good compacted stuff, bringing it up on top. We see landscapes sometimes that look like, well, here, I'll show you the next slide. If you look here, that's like concrete washout. And guess what? They laid turf on that day, just like that. There was no raking that up. There was no anything put on top of that. And actually, some of the soil doesn't look too bad. Back here, it starts to look pretty yucky, but some of this isn't so bad. But then you see this, you know, really like concrete washout stuff. And I guarantee you that that person that moved into this house, I hope it's not yours, says right here, I can never get my turf to grow. My turf just won't grow in this spot. And I don't know why. That's why. There's probably a big bunch of concrete right underneath it. And so, you know, it creates these problems in our landscape. So sometimes we're telling people, let's not keep trying turf. If it's failed 2 or 3 times, maybe we need to just put a landscape bed in there instead, or a bench or a bird bath, instead of keep, you know, trying when there could be even a big divot of different soil. So when they spread the soil out, it doesn't all mix and it's a perfect, you know, mixture of everything. There's a big pocket of something and a big pocket of something else. So sometimes, you know, it's just a pocket of soil that may not be as great for growing plants in. So sometimes we, you know, are recommending other options instead of trying to push water and fertilizer to grow plants that just really aren't going to grow there. So look at this soil down here. You can see he's on a tractor. What a difference, right? What a difference in the color of the soil. Here, I'll go back. There's, you know, what we typically see, the standard. And then here is some organic soils, like a topsoil being put back on, or some compost being put back on. So quite a difference. It can make a big difference. We've seen in research in how the plants grow. It helps them to, you know, get established faster. It also helps with water holding capacity. Okay, so let's get to the irrigation system. Let's talk about how we can make our irrigation system smarter now that we've talked about the landscape plants itself. So why do we water? Do we water because it's, you know, our day is Wednesday and Saturday? Or do we water because the landscape tells us that we need to water? And I hope that it's the latter. Now, I realize some folks go up north during the summertime, and so they do have their irrigation set to go off automatically because they're not here to see when the water is needed. In that case, please, please, please make sure your rain sensors are functioning. And we're going to talk about that in a minute. But when do you water? Well, if you walk through your turf grass and you see your footprints like this after you've walked through and they're not popping back up, that's telling me your turf is getting pretty dry and it needs some water. So definitely in that situation, you'd want to water. We also say that the leaf blades of the turf, they start to fold. They're trying to conserve their energy, so they fold up. And when you see those leaf blades start to fold, that's another sign that it needs water. But really, you should look for those signs of wilt, you know, before you water. Not brown spots, just, you know, a little bit of leaf blade folding. There's some plants out there that have, I call them indicator plants. One of them is Spiralis. It's this yellow flowering plant that gets very dramatic. It's like, oh my gosh, and its leaves are all wilty. And as soon as you water it, it perks right back up. So I have one in my yard. It tells me when I need to throw some water down to the plants. Where do we need to put the water when we irrigate our plants? Well, they use the water in their root zone. It's not necessary to water the tops of the plants. They do not need it on their leaves and flowers. They utilize the water down at the root zone. The root balls are where they need the water. So when can you water? Well, we have water restrictions in Manatee County, and the Southwest Florida Water Management District has water restrictions. And we will always have water restrictions, I've been told. No matter how much rain we get, we're always going to have water restrictions because it's kind of an educational tool that they're using to say that you really don't need to water more than twice a week. There's absolutely no reason to water more than twice a week. So that's why we have water restrictions, and we'll always have them. Now, we will tell you that you can typically get away with watering once a week. And that's what we typically recommend, is a nice deep water once a week. But in Manatee County, if your house number, so the first part of your address, those numbers are the first part of your address, whatever it ends with, if it's an even number, then your days to water are Thursday and Sunday. If it's an odd number, then your days to water are Wednesday and Saturday. Please do not water between 10 and 4 p.m. because it'll just evaporate. You'll lose a lot of water that way. So watering after 4 p.m. and before 10 a.m. is a better time. And to be honest with you, the best time, and some of you are restricted by your community, there's community schedules sometimes that tell you when you're allowed to water. And some communities like Lakewood Ranch have a variance from the water management district. So you have to water when they tell you to water because there's pressure issues with their system. But if you don't have that situation, then the best time to water is your irrigation should be shutting off right before the sun rises. So let's say the sun rises at 6 a.m. Let's say you have 4 zones of irrigation and each zone runs for 30 minutes. We're going to make it simple math. 4 zones, 30 minutes. We want the irrigation system to shut off at 6 a.m. So what time are we going to start our irrigation cycle?
4 a.m.
That's right, at 4 a.m. So we'll start it at 4. So it's just shutting off at 6. And then the sun's coming up. The plants can utilize the moisture down at their root balls. But that moisture, if it sits on the leaf and the flower, it can actually invite some fungus to come in. Okay, it can make a nice situation for fungus or other pest problems. So we really want to try not to leave moisture on our plants like all night long. So it's better to irrigate really early in the morning than it is late in the evening from the day before, because then that moisture sits on it all night. And in our hot summer nights, we can end up with some fungus because we've got the perfect environment for it then. So in the winter time, however, we want to skip a week of irrigation. When we have cool temperatures, we can actually, turn that irrigation system off and skip a week. Once it starts to warm back up, then we may need that weekly irrigation. We've got some conditions now. We've got wind. Wind can, get some of the moisture out of plants. So, right now we are needing some irrigation. It's warm out there. We haven't had rain in a few days. So yeah, this is one of those times that we need that supplemental irrigation. But if it rains tomorrow, a good rain, 1 inch or more, then we wouldn't need that supplemental irrigation. All right, this is a big water waster. And because we're promoting that you go and water in the middle of the night, essentially when you're asleep, you may not know that this is happening because it's going off at 4 in the morning. And who is up and wandering around their landscape at 4 in the morning? I'm not. So you may not know these things are happening. So this is why it's important to schedule a maintenance day that you go out and run your irrigation system, turn it on and walk around and look at the heads and see what's going on. So again, yesterday I was out and we had 2 of these on one property. One sounded like it was a fountain, like a pool fountain going off. And they didn't know because it runs in the middle of the night, so they didn't hear it.
How often should you schedule a maintenance day?
That's a great question. Thank you for asking that. So during the season when we need our irrigation, which is spring, going into summer, you should do a really good check on the system right when we start to go in. Maybe you haven't been using your irrigation as much, so a really good check then, and then a monthly check after that. So a walk around, just to listen for geysers like this. You'll hear them. If you're outside walking around, you're going to hear that. Looking maybe for soil. A lot of times when we have a leak or a blowout, you're going to see a lot of soil that's bubbled up. Like it looks kind of like an ant pile around your irrigation head. So looking for those kinds of things. And then once a month, just turn it on and make a round, make sure everything's working properly. This is another thing that can happen, and especially during the growing season, which is the warmer summer months, we need to be checking this. So on the left over here, we have a landscape plant that is blocking our spray head. So hopefully this spray head is really supposed to be spraying turf. We really want micro in the landscape beds. So now we have a plant that's blocking it so it can't spray out back here. You can see my mouse back here to where the turf is. And then in this case on the right, we have turf that's grown over the head. Now these heads, in order to keep keep the mowers from hitting them, they pop down, right? The rotors and spray heads will pop up and then pop back down into the landscape so that they can mow right over them. But what happens is the turf can also grow over them, especially St. Augustine and zoysia, because it grows like this. It can grow right over the top of the head, and it tries to pop up and it can't because it's got turf laying right on top of it with roots. So, you want to make sure when you're doing that monthly check that you're making sure that those heads are clear so that they can pop up. Otherwise, you're going to have dry spots in your turf and a big wet spot right where the irrigation head is. Another thing to look for, and this is what I was talking about with that soil movement, you're going to be looking for these types of things when you're doing that check, is the soil, being pushed out. And in this case, underneath this, what we call a donut, and the donut helps protect that irrigation head. Underneath there's a crack. And that happens quite a lot, especially next to driveways and sidewalks, where sometimes cars hit even the top of this that's sitting out. So you've got this hard thing like this, and right underneath it is a pipe, okay? And so if this gets knocked, sometimes it cracks right here where the pipe and the nozzle are connected. And so it's underground, it's pushing up all the soil underground where that crack is, and that's what causes that. So they have to dig it out and, replace that pipe that's been cracked. There is something that's a flexible type of pipe. So if you're having that issue, especially next to the driveway or sidewalks, you can get those flexible pipes that go in. And then when you have, your nozzle that moves, it kind of flexes with it a little bit. And this is a line break here. So you can see that, you've got a line coming into this head. The head's not able to throw any water now because there's no pressure to make it throw water. And you've got this line break right here. So again, this is a visual. You wouldn't hear this one, the soil being pushed out, but the line break you'd probably hear. Okay, and to save water, aside from going and checking your irrigation system and doing your maintenance once a month, we need to separate our landscape beds from our turf beds. Landscape plants do not need the amount of water that turf does. Anybody know why? Any ideas why?
Because turf isn't really native to Florida, and so it's going to require more water.
Somewhat, but think about the roots. Okay, think about the root systems in the soil. So you've got landscape plants. Let's think about oak tree. How deep do you think oak tree roots go?
deep.
Probably until the water table, right? They hit the water table and they stop there. But they can access that moisture very deep down in the soil. And the moisture stays longer, deeper down in the soil. When we have, you know, the soil starts to dry out, that top layer of soil dries out first, right? And it takes longer, the deeper you go, for the soils to dry out. Where are turf roots at?
Right at the
Turf
top.
roots are, yeah, you're doing good if you've got 6 inches of turf root. Okay, that's a good healthy turf. Most of the time it's just a few inches of root, especially in these compacted soils. It's hard for them to really get their roots established, so they're not so deep. So that soil is drying out very quickly up at the top, and it needs to get the moisture replenished to keep the root systems moist for the turf. And so that's why turf requires more moisture. It's just its root system can't go down and access that moisture deep below, where the landscape plants can. A lot of our landscape plants have much deeper root systems than turf, and so they can access that moisture. So they don't need as much water as often. So we want to have them on separate zones in our irrigation system because of that. Turf needs what we call high volume irrigation, which are our spray heads and our rotors, because we need to get it out in this nice, even, you know, consistent way, and we need to get it to perk into the soil so that the entire blanket of turf that we have out there as root systems gets covered. Where our landscape plants, we really just need to irrigate the root balls of each of the plants that we have. So that's when we talk about using the micro irrigation. I'm going to show you what that looks like, so that it can be directed right to the root systems of the plants and not this full blanket application into a landscape bed. Because if you're not irrigating the plant in a landscape bed, guess what you're irrigating? The weeds, right? So if you're not hitting the plants that are in there, then you're hitting bare mulch, which can hold weed seeds, and that can cause the weeds to, you know, it can help the weeds to grow, not cause them to grow, but it can help them to grow. So we want to separate our landscape beds and our turf grass. And sometimes we even need to break our landscape beds down into different zones depending on their water needs. Now, if you absolutely have to have impatiens and petunias for whatever reason, they need to be on a different zone than some of our ornamental grasses that don't require as much water, right? If you have petunias and cord grass, which rots out and gets fungus if it gets too much water, if you put those together in a landscape bed, somebody's not going to be happy. The petunias will be dry, or the cord grass will fungus out. So one or the other is going to constantly happen. And so they would need to be put in separate areas on separate zones. Most grass needs 20 to 35 inches of irrigation water per year, where our woody plants that have those deeper root systems really only need about 10 inches of water a year. Look at that, pretty graphic. All right, so we do this by, again, separating into zones. We want our turf zones to be on one system, on one zone, and it would all be high volume. And then our landscape beds on separate zones, and that would be low volume. So how do we start to accomplish that? Again, shrub beds, we want to use micro or drip, where we would use the spray heads or the rotors in turf. So with our sprinkler spacing, let me click here and see if that, there we go. With our sprinkler spacing, we want for the turf areas now, again, we're trying to get that kind of blanket coverage of water to get to all the root systems in our turf. We need to make sure, number one, you can see here that that spray head is popping up all the way and that the turf isn't blocking it. And then the same here. This is a rotor. It shoots that single stream. And then this would be a spray head, which kind of shoots like a spray out there, a constant spray. So we need to pay very close attention to the spacing and how we accomplish this blanket application to our turf. And so we need to look at, with our rotors, this is the old-fashioned impact. You remember these? They went, people used to love to listen to them. Now we have the rotors with the constant spray, no more sound effects. But these, if you see, it would spray out this way, and then it would kind of make this circle where the water would be hitting out in this circle area, but it's throwing, oh, I'm sorry, I'm on the wrong slide. Let me go over here. It would be out in this kind of circular pattern here. The thing is, it's throwing the water in an arc, okay? And underneath here, there's not really any water that's being applied because it's throwing the water way out here. The same is true with your spray heads. You can see it right here. See, it's throwing the water out here, but not much water is being delivered down in this area. So you need to have the heads, what we call head-to-head coverage, where we have a head nearby that is throwing the water in this area. And up here, you'd have a rotor over here that would throw the water into this area. And so what you're trying to do is something that looks like this, head-to-head coverage. So this spray head or rotor is covering this area here in this semicircle. But then we have this rotor or spray head that's throwing back under here to get this area nice and wet. And we have this to throw over in this area to get it nice and wet. Okay, so we've got to have this kind of overlapping of our spray heads and rotors to get a consistent coverage in the area. Does this make sense? Does anybody have any questions about this part? Okay, great. All right, so we want to have 100% overlap. There's ways, and I'll show you in later slides, of how we can kind of test this and check it and see if we have this, what we call uniformity, or this, uniform coverage out there. We want to make sure that we don't have too many heads. We want the adequate amount of heads to achieve this blanket coverage, but we don't need to have too many heads, because if we do put too many heads on one zone, then we overtax the pressure. So then we don't have enough pressure to make them work properly. Okay, so you can't just go out and say, oh, I have 8 heads out here currently, and I think I need 4 more. You can't just go and install 4 more heads without checking your pressure, because when you do that, you may pull too much pressure out of that line and none of the heads will work appropriately then. Okay, the way irrigation system works is totally off of pressure. What happens is the valve opens, the line fills up and pressurizes itself, and once the line is full, that causes everything to pop up and start working, right? So if we have a leak somewhere, it can't pressurize itself, right? Because it goes to fill that pipe and it just keeps running and running, and so it can't pressurize to cause everything to pop up and start spraying. Same is true if we put too many things on. There's just not enough pressure to make the things pop up and start spraying like they should. All right, so let's look at this controller. A lot of times people have never touched their controller. They don't know what's involved. This is a little bit of an older controller, but the components, the pieces are still the same on all controllers, which is nice because I can walk into anybody's garage and look at their controller and know how to operate it because I'm looking for the same things. Okay, so the first thing let's talk about is our watering time per station. So our watering time per station, we have stations or zones out in the landscape, and we need to set how long we're going to run them. All right, I'm going to tell you that you need to put down at least 3/4 of an inch of water per irrigation cycle. If you have sandy soils, we're going to up that number because sandy soils don't like to hold moisture. So we're going to up that number up to an inch to maybe even an inch and a half, depending on how sandy it is. But at least 3/4 of an inch of irrigation per cycle. Okay, but how are we going to do this? Because our controller wants us to put in minutes, not inches. It'd be lovely if I could type in, 1 inch and it knew how to do that, but it doesn't, unfortunately. We have to tell it how many minutes to run to get 3/4 of an inch of water. So how do we do that? Any ideas on what to do here? Okay, I'm gonna get there with you. So why do we want, well, first of all, we want 3/4 of an inch of water because in a good soil, a not compacted, somewhat organic materials in the soil, 3/4 of an inch of water will get watered down 8 to 9 inches. Okay, it'll get 8 to 9 inches deep of moisture, which is going to hit all those root zones of that turf, which is what we're trying to do. And it's actually going to push past a little bit, which is even better, because if we can get the moisture down here, we're going to encourage these roots to grow down to the moisture. And that's what we're always trying to do, is trying to get our root systems to grow deeper into the moisture. That way, because if we don't, let's say we only water for, put down 1/4 of an inch. Okay, so 1/4 of an inch, it would only give us like 2 to 3 inches of water. So right up here, our root zones would stay here, right? And what's going to happen when we have a drought and it's hot and it's dry and windy? There's not going to be enough water for those plants to survive and your turf's going to brown out. What if we have a drought and we go to, you can only water once a week. You can't water for, a 1/4 of an inch every day like you've been doing. Your turf's going to fail. So we always want to irrigate to encourage that very deep root growth to try to make our landscape as drought tolerant as possible. So this is why we recommend this 3/4 of an inch. Again, we're trying to get the water 8 to 9 inches deep. If you have sandy soils, it takes a little more water because that water is gonna run right through. So we recommend a little bit more water. So 1 inch to 1.5 inches, depending on how sandy it is. So this is how we're going to determine the time that it takes to get 3/4 of an inch. Okay, we're going to set out, and I have these. If you want them, we will get you calibration kits. Ours don't look quite like this. They're yellow and they're little rain gauges. Or yes, thank you. Judy's holding them up. Perfect. So you can also use tuna fish cans. That's a very common one that people say, cat food cans. But what you do is you would put these randomly out into the zone that you're wanting to test. So whatever zone you're wanting to test, you would just randomly put them out there. These are set up in kind of a grid. We're not interested in grids, just scatter them. Then you run your irrigation system. And I typically say to do it for 10 minutes just because it makes the math easier. So run your irrigation system for 10 minutes. Then you're going to go look in your little rain gauges or your tuna cans or your cat food cans, and you're going to see how much water you've collected in each can. The first thing we want to note is, are all the cans the same depth of water? Do they all have about the same amount of water in them? If you have one can that's full and one can that's empty, you have a problem. You have to kind of start looking and scratching your head. Is there a tree blocking the irrigation head that it can't spray into that can? Is that irrigation head clogged and not spraying properly? What's going on? So the first thing we want to look at is, are all the cans or rain gauges, are they about the same water? Not exactly the same, but about the same. If not, we need to start diagnosing what the problems are. But then we're going to note how much water we collected. So in 10 minutes time, let's say we collected 1/4 of an inch of water in all of our cans or catchment containers. So 1/4 of an inch of water we collected in 10 minutes. How long would we have to run our controller, our zone, to get 3/4 of an inch of water?
30 minutes.
30 minutes, that's right. So this is how we know how long to run our timer. Unfortunately, I can't go set 3/4 of an inch on my controller. I can only set it in minutes. So I have to run the system to see how many minutes it takes to get 3/4 of an inch of water. Okay, and it's going to be different in different zones, believe it or not, because of the way the spray patterns and the areas that you have that you're covering. So it'll be different in each zone. All right, so you can mark if you're using a tuna can at the 3/4 inch depth, or if you have the rain gauges, they're already marked for you. You want to use 6 to 10. Perfect. Thank you, Judy. She's showing you how that we have it all marked for you. We typically give 6. I think, was there 6 in your pack? We usually give 6 of them out in a
Yes,
pack.
6.
And you just place them randomly in your zone. And then you'll have to do the math, and then you'll repeat that for each zone on your system. And that's going to tell us how long to set our run time. Okay, all that to set that. Okay, what about our start times? So now we've done our calibration. We know how many minutes each zone is going to require to get 3/4 of an inch of application to it. When do we start? Well, we know we can't start it between 10 a.m. and 4 p.m. because that's actually against the water law out there. It's against our water restriction. But we talked about this before. However many minutes it takes for all of those zones to run, now that you've done your math and your calibration, however many minutes, you're going to back it up from sunset, or I'm sorry, sunrise, excuse me, from sunrise. So right now, sunrise is around 6 a.m. I would say 6:30 maybe, I don't know. You can plan on 6 or 7 a.m. and you'll always be about right. And that's not the crucial. You don't have to set it right at when the sun is rising, but in that area is what we're shooting for. So you'll back it up from 6 or 7 a.m., whichever you choose, the number of minutes it takes for the complete cycle to run all of your zones. All right, so that is this area of the controller is your program start time. So we have a publication that talks about, some other controllers as well, but you can look to your controller's manual to learn how to do this, but they're usually typically labeled pretty well. And so the program start time is referring to that. It's referring to what time do you want the system to start? And then it's going to run through each of these zones watering times that you have set. Okay. This particular controller has 3 different start times. So if you wanted to, you could turn it on 3 different times during the day that you choose to run on. Why would we want to do that? Any ideas as to why we might want to do that? Well, if you have those really compacted soils, let's say 30 minutes, let's use 30 minutes as our run time. Those really compacted soils, after about 5 minutes, maybe not even that long, any water that hits that compacted soil just runs right off of it. So for 25 minutes of your 30 minutes, you're running water off of your landscape. So what we would recommend is what we call cycle and soak. So we would say run the zone, well, it would be run all of your zones really for 5 minutes. So you would set your first start time. Actually, let me back up. You can divide on this particular controller. You could divide your time in half, or you could divide it into 3. So on this particular controller, you could set it for 10 minutes to run. The goal is to get 30 minutes overall, right? But you'd set it for 10 minutes on each of your zones, 10 minutes on each of your zones, and then you'd set your start time at 4 a.m. Okay, so at 4 a.m., it's going to run each of your zones for 10 minutes. So it's going to push some water in there, allow some of those soils to open up a little bit, get some water percolation in there, run through all the zones, and then you're going to set your second start time. How many zones do we have? Let's say we have 4 zones and we're running them for 10 minutes. So the second start time would start at 4:40, right? 4:40. And then we're going to run each of the zones again for 10 minutes. A little more percolation, little more water getting down a little deeper into the soil, because these are compact soils, right? Then the third start time. So now 40 minutes on top of 4:40 would be 5:20, right? 5:20 would be our last start time, our number 3 start time. And then it would put down 10 minutes on each zone. So what we're doing is we're watering for 10 minutes. We're letting it take a break while it runs the rest of the zones. Then we're coming back, watering for another 10 minutes, letting it take a break, and it's percolating down a little deeper each time. We call that cycle and soak. And that's how we help to overcome irrigation issues on some of these really compact soils. If you have sandy soils, you don't need to worry about this. You set one start time, you water, very deep. But with the really hard compacted soils, that's a big issue, is a lot of it's just running off. So we really need to divide that time up into multiple start times so we can get better percolation of the water into the soil. Are there any questions on anything so far? Okay, I will move on.
Michelle, can I just comment? I've never understood how to run that. So you just gave such an easy explanation.
Oh, thank you. Well, good. That is very, very common. We hear this quite a lot.
I've asked our landscaper before to show me, and he flip, and do this and all that, and I've not understood it. So I feel like I'm going to go out now after this class, look at it, and I'm going to understand it. So thank you.
Good. Well, another comment that we hear is that their landscape company told them not to touch it.
Yes.
Don't touch that.
Yep.
Yeah. So no, you should know how to do things like turn it off. When you're having a big geyser out there, you should know how to be able to turn it off. And there are things that you should understand. So there are some smart technologies out there that can help us with saving water. One is a rain sensor. And I'll show you what that looks like in a minute. But a rain sensor essentially says, okay, it's rained enough water, enough rain has come down that the system doesn't need to run. So that rain sensor will keep your system from running when we've had adequate rainfall. That's a huge water savings, Then we have soil moisture sensors, and we'll look at those, which actually go in the ground and measure the moisture of the soil. So when they're installed right and functioning properly, they actually can save more water than a rain sensor, because it's actually looking at the soil moisture and not like what's going on in the air. Okay, so it's actually looking at what is in the soil and is there adequate moisture for the plants to continue to thrive in the soil. And if there is, then the system won't run. If there's not, then it'll allow the system to run. And then there's the weather-based controllers. Now, the weather-based controllers look at wind speeds and the solar radiation, how intense the sun is, the amount of rain, of course, but it's taking into consideration a lot of things before it determines whether the system should run or not. The basic, most easy way, if you don't have the technology, is a rain gauge, or if your technology is broken, a rain gauge. If you've had, well, it says on here a half inch or more, we typically say, you know, about an inch or more, then you can skip the irrigation. Skip the irrigation. If we've had adequate rain, you can turn off the system. If you don't have a soil or a rain sensor or a soil moisture sensor or a weather-based controller, then please have one of these and keep it clean and, you know, dumped out so you know when to turn on and off your irrigation system. Okay, so this is what a rain sensor can look like. They can look a lot of different ways, but this is the one we most commonly see out there. They have inside them little corks. There's like 5 or 6 little cork discs inside them that when it rains, they swell up and like flip a switch inside. Okay, and when it's dry, they dry out and they compress and it allows that switch to go again. So it kind of turns the switch on and off by swelling of these corks. It sounds very simplistic, but it's kind of high tech, to be honest with you. The way it's all calibrated is pretty interesting. So we typically find them at the edge of the rooftop or near the air handler for some reason. But what we want to be sure that you're doing is if it is near your air handler, that it is at least 5 feet away. Because this is picking up on moisture in the air, and this is running a fan all the time, this air handler can actually dry out your sensor and give it an erroneous reading. Okay, it could have just rained and it's summertime and you're running your AC constantly like I do at my house. So it's drying out this sensor. So you want to make sure you're at least 5 feet away so you don't get an erroneous reading from the fan that's blowing it dry. Some interesting things that we've seen out there. Let's start here. This is an irrigation system running. Here is the well pump. This right here is the rain sensor. Guess what's being sprayed onto the rain sensor? So hopefully this is the last zone in the run and not the first one, because if it's the first one, then it's turning the system off and the rest of the system's not running, right? So you got to be careful where you mount these guys. This one is hanging here, but the interesting part is it's under the eave. So is it going to be open to rain? It's not going to get a good reading for us. So mounting these things, you want to make sure that you're mounting them right. Okay, this is kind of an older soil moisture sensor. Now they make them that have like just 2 little probes that stick in the ground. They also make them wireless now. You have to check the batteries though. Now there's a battery component, but the essential pieces that they go in the soil, they go in the root zone. So in this case, you can see the turf's been flipped up. It would go in that root zone area and it would be measuring the moisture of the soil in the root zone area. So it would tell the system there's adequate moisture, don't need to run, or it's too dry, run the system. Okay, now it is not a live feed like if you've been to the land at Epcot that as soon as a plant needs something, it rushes it to the plant. Okay, that's not how these systems work. Your controller is still set for 2 days a week. If there's adequate moisture on the day that the system is supposed to run, then it won't run. If there's not adequate moisture on the day that your system is set to run, then it will run. Okay, it's not like this says, oh, I need moisture right now, and it turns the system on to run a cycle. Okay, it's still only going to run on the days you have programmed to run. Does this make sense? Okay. All right. Weather-based controllers can look a lot of ways. They are going to measure temperature, humidity, wind, solar radiation. There's a lot of things that they can look at. They can operate a couple of ways. Sometimes it can be an on-site whole weather station. You can have one of those, tensiometer, is that what it's called? The wind speed thing, right there on your site. So it's measuring everything on site. Or it can connect to a weather station nearby with internet. Okay, so it can have an internet connection and it can be connecting to a weather station nearby. Of course, the best one is to have an on-site weather station, because in Florida, your house could have rain and the house across the street could be dry, right? Seen that before? So having it down the street or down the road, or, you know, further away, may not measure what's going on your property, but it's still, you know, it's still pretty good. But the best one is the actual on-site weather system, just because it's Florida and we have, you know, weird conditions here. We did notice that there was, you know, good savings by using these. Our researchers look at this intently, and we did find more savings in using one of these than using just the rain sensor itself. Again, that's the assumption that these are set up properly and maintained properly, okay? The subscriptions, this may be an old number now, but there's like a monthly subscription if you are tying into, you know, a system, a weather station nearby. Sometimes there can be a subscription. And then there's the initial cost to install it. So the controllers themselves can be smart. We can use smart technology to operate the controller, like the rain sensor, the soil moisture sensor, and the weather-based controller. But the controller is just telling the system to run, right? So the controller is telling the valve to open up and run water through it. And so I guess these got out of order, but when the valve opens up, what's it going to? Is it going to a rotor? Is it going to a sprayer? Is it going to micro irrigation? This is the water source, is what this is supposed to be representative of. In this case, it's a well. It could be your meter at the end of the road. It could be a pond, but typically it's going to be one of those things. So you're going to have your source that goes to the valves. The controller controls the valves, and then the valves send it out into the zones. Okay. So again, here's another type of controller, Rainbird. There's actually an even newer one. This is the ESP, but now there's the ESP-ME that we're seeing a lot of these days. But same stuff, you know, run times, start date, everything's pretty much the same. So you've got your main line coming in, and then you've got your controller that is wired to these valves. There's an electronic wire that tells the valve to open up or close. So you need to be careful when you're doing maintenance in these areas, because there are wires there. And if you cut a wire, then your zone's not going to run. Okay. This is what the valve box can look like. Let me give you a little helpful hint. There is no building code. There is no requirement, restriction, best management practice, anything for irrigation. It is a fast and loose and Wild West type of installation. We have some very good contractors out there who really know what they're doing. And we have some people I call chuck in a truck that have a pipe and a pipe cutter and think that they can do everything, right? So you have to be sure that you're, you know, seeking to find a good quality company, because there aren't any restrictions. There's no license requirements in Manatee County that you have to have a license to do this. So they can kind of do whatever. And these valves, sometimes we find them all in a box like this. Sometimes we find 3 on one side of the house and 3 on the other side of the house. Sometimes we find the valve in the zone itself. And so if you have 5 zones, you could have 5 places where your valves are going to be. And it gets a little tricky when you're trying to retrofit or you know, diagnose issues if you don't know where your valves are. And then the irrigation guy comes out and he has to use special equipment to either trace the electronic wire or trace a water pipe. So there's two different pieces of equipment that they can use to try to trace these things. Try is the word there, right? It's not always successful, but they can try to locate your valves, and those pieces of equipment are expensive. So that can get costly for you if you're having to identify your valves. So if you're out messing around in your landscape and you come across a valve box, I would put that on a map somewhere. Make a diagram of your landscape, identify where your valve boxes are, because it can save you a lot of money when it comes to time to repair things. The newer builds, though, the newer houses typically have them all located in one box like this. And it's typically close to the garage, because that's where the wires go to, is inside or outside on the garage wall to the controller. All right, so the irrigation controller by itself, all it is a timer. That's all it is. It's just a timer. So it's going to tell, when to turn on, when to turn off, but it has no awareness of the weather or soil moisture or any of that stuff. You have to have those things hooked up to it additionally. Okay, I don't know why there it is. Okay, so down here on the controller, or it's located in various places, there can be this day cycle thing, or there can be program A, B, C, and D. I'm telling you these little things because they can alter your time. So let's say you have this system where you've got programs started and you're doing a cycle and soak. So you have 3 programs set to all run on Tuesday. Okay, Wednesday, let's keep it in the water restrictions. On Wednesday, you're going to run all 3 of these, but you're on program A. Okay, in a different controller, you're on program A. But then you start messing around with things and you don't realize it, and you go to program B and you're like, hey, where'd my time all go? It's gone. I better reset it again. So you set everything up again in program B. And then you get to program C and it's like, my time keeps disappearing, and you set it up again. What you may not realize is you're setting it up so that it's going to run A, B, and then C. Okay. It will run all 3 of those programs. And I'm telling you this because these new controllers have A, B, C, and D with 6 start times, up to 6 start times. I know you can run 24 cycles on these new controllers. So you have to be sure that you're only on like program A, you're just messing with one program. So that you're not in a separate program putting that time in. I had a lady whose water bill was up $2,000 because she was in her controller messing with it and didn't realize she was on all these different programs setting time. And now it's going to run. It was running for like 12 hours every day, this controller. And this what the picture's showing, and this controller, you see this day cycle. So this one's set to custom, so that you go up here to the custom schedule and tell it the 2 days you're allowed or the 1 day that is recommended. If you put it on one of these, like if you were to set it to 5, it's going to run the program 5 times that week. So for 5 days a week. If you set it for 3, it's going to run it for 3 days that week, or 2 for 2 days that week. So you just have to be careful, even though you've got your start times all down and you've got your zone run times all down and you've got your days all down. Make sure that you're only running, one program, or that you've got it on custom and you're not set up for it just to automatically run for 5 days. Okay, because that can rack up some water real quick. All right, so let's talk about the sprinklers themselves. So again, controller is just a timer. It says, whoop, turn on the valve, turn off the valve. So the controller turns on the valve. We've got this rotor here. It's spraying out a jet stream. and dispersing the water that way. Rotors can be spaced really 15 to 100 feet is kind of where they optimize. There are some that go like 8 feet, but in that range, you really can get away with a spray head instead. So these are for like big spanses of turf. Okay, otherwise you can use spray heads. They need to have, this is pounds per square inch. They need to have some pressure to make these things spray out this amount of water. Large open areas, their precipitation rate, which is that PR, and I keep getting on the wrong slide to point to things, the PR precipitation rate is about a ½ inch an hour. Okay, so in about an hour's time, they're going to put out a ½ inch, which is important to know because it takes longer a lot of times for rotors to apply the water because there's not spraying a constant stream all in one spot, right? They're hitting just where they're spraying. So it takes longer for them to get a blanket of, 3/4 of an inch down. This is what they look like inside. There actually is a little screen in there, a little basket. So if you're on reclaimed water or especially reclaimed from a stormwater pond, you might need to check that basket occasionally because sometimes stuff gets built up in there and it needs to be cleaned out. So if you have the tool, then you can pull it apart and do it. Otherwise, if you're using a landscape contractor or irrigation contractor to do maintenance for you, ask them about this. Ask them if they're cleaning those baskets out for you, because that should be part of their service. You can adjust these rotors a lot of times. They have a spray pattern and you don't want them to be spraying on your hard surfaces like your driveway or the wall of your house. Each manufacturer has a different tool. Sometimes it's just a little screwdriver. Sometimes it's this little tool down here that you poke in and adjust, but they all have an adjustment on them so that you can get it, so that it's spraying in the right area. The pattern and rotation varies among the manufacturers. So, always go to their website and get the instructions on that particular model if you want the specifics on what you're running. But know that the rotors, they typically come in a 90 degree, a 180 or a 360. Yeah, you can do 275 too. So they can spray all the way around in a circle, or they can just spray a little pie shape, right? 90 degrees. Some of the newer ones, or there are some that you just buy one rotor and you adjust the pattern on the rotor itself. So you can adjust it to 90 or 360. Some manufacturers make it where you have to buy a 90 degree and you have to buy a 360. So that's why we say you really have to go to the manufacturer to see what type of rotor it is, because they're all different. Spray heads are the ones that pop up and spray a continuous spray. It's like a full spray pattern. So they often don't take as long to get the same amount of water down, but they're for smaller spaces. So, oh, come on. You would use them more in the, even from 4 foot to 15 foot area. Anything larger than that, you're going to need to get the rotors, okay, because it's too big a space for the spray head to cover. They don't need quite as much pressure. Again, that's pounds per square inch. They don't need quite as much to make them operate because it's not as much water going out. And their precipitation rate in an hour period is about 2 inches. So on the rotor, it was a ½ inch. So you can see they put out, because it's a continuous stream of water, they put out more water in a smaller period of time. You don't have to run them for as long. Your run time won't be as long with the spray head. And then we have the micro, which I'm showing you in these pots so you can see kind of how they work. But micro irrigation is usually a tube of water that little spaghetti tubes or some kind of emitter hitched to, and then they water specific plants. Instead of watering all of this mulch area out here, which can water your weeds for you, you're watering specific plants and getting the water in a very specific area to save water instead of that kind of blanket application. There's lots of different types of micro irrigation. You've got these little micro sprayers. Some people like those. They would go kind of under the shrub. Um, the micro here, sorry. There's drip tube that these holes, it would actually, the hole would be on the bottom side, but the hole, it drips out the water. And in this case, these holes are spaced either 12 or 18 inches apart, depending on how you buy your tubing. And this would be good for like those ground cover areas or annuals where you have a lot of plants in a small area. When you have like just a row of hedges, then something like a shrubler, like this guy here, which is, you know, putting out a little bit more water, but only in one area, would be a more effective way to handle that. And then you have the little drippers too. So there's lots of different ways, and people do it on preference. A lot of times, some people like these micro sprayers because they can see that it's working versus the drip tube because they don't see it, because you typically put it under the mulch and you never really see it. The way that you know it's not working is your plant starts to wilt. And then you're like, I think that I might have an issue there. So drip tube also has a maintenance component to it. Let's talk about these individually though. So the micro sprayers are, you know, you can change these little emitters out to be different fan sprays, to be different amounts of water being applied. So you can very much tailor it to the needs of your landscape. You install them on these little stakes or risers, and you know, they spray, they're good for mass plantings. The problem with it is though, is it wets the foliage. So in this case, you are getting that water up where it's maybe not so necessary. So if this were a shrub, this would be a better option under a shrub because it's not going to get the foliage. In this case, you've got more of a ground cover. That drip irrigation is probably a better option. But in this case, so you've got more of a shrub, it's getting it down into the root system area. And again, some people just like this type of spray because they can see it spraying and they know it's working versus the drip tube. So you have your distribution tube in this case that gets the water to the area, then a little spaghetti tube. Then you would have a stake with your emitter. Oh, and it drops. See, there's another one of those mistakes I need to fix. Then we have shrubblers, and shrubblers stay close to the ground. They put out, you know, maybe a little bit more water. They can spray in spray patterns. And the good thing about the shrubblers is they can be turned off. So you actually right here on the caps would turn it and you can turn it off. So once your shrubs are established and they can go deep down into the soil for their moisture, you can turn them off and save water. Okay. And they are good for establishing larger plant material because they can put out more water to the root ball. Okay, so we talked about that already. Okay, so then we've got the drippers. Again, you can see the water coming out. In this case, your drip emitter would kind of be up where you would see it dripping out. You can put it on spaghetti tubes where you could see it dripping out. But typically, if you're going to go with drip, we see this drip line is more the norm. So we have emitters that are inside. Oh, I love how this is everyone. Okay. Emitters that are in here, you can actually see like right here, you can see kind of the pipe is a little different. What that is you've got your water moving through the pipe. And then there's this little, we call them rat traps, believe it or not. It's a little catchment and it forces the water to zigzag through it. And when it's zigzagging through it, it's catching any particulate, like little pieces of dirt or mold that might be in the line. It'll catch those in this little rat trap before it sends it out that little hole. Why is that important? Well, you don't want your holes clogged up, right? So it can catch those little pieces. But it does that, let's say for, a year. What happens over time is those little rat traps can get plugged up. So what you have to do on drip tube is what's called a back flush. So at the end of the line, they should have a valve that opens up entirely or a crimp that they can pull off. And at the end of the line, once a year, you open up that zone, that line, and let that water flow right out. And it back flushes all those little rat traps and it cleans the line for you. So once a year on drip tube, you should be flushing that line out. Otherwise, those little rat traps in there that are catching all that particulate can get clogged up. They are often pressure regulated themselves. So there's fewer pieces and parts. It stays out of sight because it's under the mulch. A lot of, good things. The only thing is that, again, it's hard to see because it's under the mulch if it's working or not. So you have to kind of pay attention to your plants and make sure that they're not showing wilt. So this would be one type of design that you could do if you were doing like a ground cover in this area, so that you could plant the plants pretty close together and still get coverage on them. If you were doing shrubs, you could circle it so that both the one side and the other side of the root ball receive some moisture from the drip system. So there's lots of ways to install it. Lots of technology out there, lots of different smart technology, ways to save water with our products. And then these are some of the resources that I used to get information or show pictures from. And with that, I'm going to entertain any questions that you guys might have on anything that we covered today. I know it's been a lot.
What I'm seeing as far as all of the micro irrigation is the pictures you showed us. I know it's for to make it simpler to see, but this is all on new construction. There's no mulch. I've got a backyard that's very shady and it's got lots of mulch. And how would they have to tear up all that mulch and get underneath that to put in a system, or how does that work?
No, so what they would do is they would lay it on top of the mulch and get it all installed right on top of the mulch. And then they would just, like you would a plant, move the mulch aside and then kind of bury it. Okay. So no, the drip system's really easy. Now, if you're installing, all new irrigation, then you're going to have to dig and all of that with your lines. But for just a drip system, it's really easy. They can just lay it right on top and then bury it under the mulch.
Gotcha.
Drip systems, you can retrofit. Like if you have a zone that has spray heads on it, that's watering your landscape bed right now, it's really easy to retrofit that to micro. You'd have to do, of course, the whole zone to micro. You couldn't have spray heads and micro on the same zone, but you could retrofit that pretty easily.
Okay.
Lots of pieces and parts now out there in the market to retrofit. Okay, thank you. You can definitely email any questions that you have to me. I'm looking at a chat here. Oh, yes, certainly. Email any questions that you have anytime. We're always happy. We're educators. This is what we do, right?
What are your recommendations for hand watering efficiency?
Okay, so hand watering efficiency, it would basically be the similar concepts in that you don't want to water between 10 and 4 because it's just going to evaporate, and you want to get the water to the root ball, not up on the leaves. So when you're hand watering, try to get down as low as you can. There are no water restrictions on hand watering. Okay, because you're hand watering, they assume that you're going to go turn off that valve. So that's not turning on a sprinkler and letting it run. That's actually holding it in your hand and watering, but getting it as close to the root ball as you can is good. And if you see a lot of runoff, then coming back, turning it off and coming back a few minutes later, because sometimes even garden soil and stuff sometimes can get a little hard, especially if it's got a lot of peat in it. It can get hard and compact and it'll start running the water off. So you just give it a little drink to open it back up, and then it's more likely to percolate the water. So you may have to water a little, turn it off, and then come back with a longer watering. Is that what you were looking for?
Yes, thank you. And is there a kind of significant difference between hand watering and using like a micro irrigation or drip system?
Well, typically, statistically, we show that less water is used in hand watering just because we as humans tend to be lazy and don't get up and go hand water. But when we have a controller that just automatically kicks on every, twice a week, it just is going to run. So we typically find more water conservation with hand watering.
Thank you.
Certainly. Thank you. Thanks for the question. Anything else? Well, thank you guys for your time. Thank you for your efforts in conservation. It's truly appreciated. As a Florida manatee girl, I'm always happy to talk to folks about saving our water and protecting our water resources. So thank you very much.
I have one more question. As development continues here in Manatee County, do you think there'll ever come a time when people will start putting down stones instead of grass? Because they have to. Because they have to.
Yeah, I hope not. And actually in Gainesville, they're working with some communities. There was a community up there that got permitted if they used a water budget for each home. And the water budget is like 200 gallons a day per person, no, per house, 200 gallons a day per house, which when you start to look at that, doesn't give you enough water to do irrigation. So they're not going to have the water budget to do irrigation like we do irrigation down here. So it's going to change the look of the landscape in this development. They're going to have to use more native type plants, more plants versus turf, because we talked about why turf uses more water. Turf is not the devil. Please don't think that I'm saying you should not have turf, because there are good reasons to have turf in certain situations, but turf does use more water. And so if you don't need the turf for a specific reason, then maybe consider a landscape bed that doesn't require as much water. And these communities are going to have big foundation of the house, small landscape, and the landscape will consist mostly of landscape plants and probably natives that don't require as much water.
Who can I address a question to concerning turfs that grow in heavy shade here in Florida?
So there are a couple that grow, but when you say heavy shade, that negates turf, period. Heavy shade is not turf. You need a ground cover. And so there's things like Asiatic jasmine that can handle dense shade. There's some ferns and things like that that we could recommend, but turf requires at a minimum, even the shade tolerant turfs need at least 4 hours of sun, but most turf needs 6 hours of sun. So when you say heavy shade, you're not going to get turf to grow there.
Okay.
Okay. Well, if there aren't any more questions, I just want to thank you again for your time and your efforts to conserve our water. And you have a wonderful day.
Thank you very much.
Thank you, Michelle. Thank you.
Thank you.